FLOSC, dear Mr. Isaac Shaboni, Dean of the Faculty of Electrical and Computer Engineering, dear participants, organizers from FLOSC, local and international guest speakers, and friends of open technology. Ladies and gentlemen, it is a pleasure to be here with you at the 10th edition of Software Freedom Kosovo, the largest open source conference in our region, which has placed Kosovo firmly on the global map of technology and collaboration. Over the past decade, the FLOSC, the community of Free Libre and the open source software of Kosovo, has shown that passion, cooperation, and civic engagement can bring real and lasting progress. Through your work, Kosovo has hosted major international conferences such as DebConf and FOSS4G, proving that our country can both organize and contribute meaningfully to the global open source movement. FLOSC has also played a key role in improving coverage of Kosovo on OpenStreetMap, helping create freely available geographic data that supports better navigation and planning. In one word, FLOSC has put Kosovo on an open source map of the world. Software Freedom Kosovo 2025 continues this mission. It brings together developers, researchers, students, innovators, and thinkers who believe that knowledge should be shared and technology should serve people. This conference brings local and international speakers, contributors from communities such as Wikimedia, Arduino, and others, as well as participants from right here in Kosovo who are building open source projects used by thousands around the world. I understand that there are already successful contributors from our country whose work is helping to shape the digital tools and knowledge that people everywhere rely on. Their achievements show that Kosovo's talent and creativity are global in reach. Open technology is not just about software. Open hardware is equally important. It allows people to understand, modify, and build the devices they use every day. It empowers students, engineers, and creators to learn from each other, to innovate locally, and to make technology that truly serves their communities. Open hardware, like open software, gives us independence, transparency, and the ability to solve problems together. This community represents something greater than technology itself. It represents openness, collaboration, and the belief that shared knowledge creates shared progress. And this spirit is essential for our digital and social future. The government of the Republic of Kosovo supports this vision. Open technology, quality education, and cooperation across communities are important enablers of national development. To the young people of Kosovo, I encourage them to learn and study, to engage and contribute, and to take part in this global movement. Every contribution you make, whether it's a line of code, a hardware prototype, a map improvement, or an edit to Wikipedia, helps build a stronger, more connected Kosovo. And as we look ahead to the era of artificial intelligence, we must ensure that AI also speaks Shqip, so that no one is left behind, and that our language, culture, and creativity continue to live and grow in the technologies of the future. I see a clear role for open source in open government as a foundation for transparency and better e-services for citizens. By embracing open source, we not only strengthen our own institutions, but also learn from the experience of trailblazers around the world, standing on the shoulders of those who have advanced openness and digital government globally. I thank the organizers, FIEC of the Public University of Pristina, volunteers, local and international speakers, and all participants for your commitment and contribution. I wish you an inspiring and successful conference filled with new ideas and partnerships that will further strengthen Kosovo's role in the global open source community. Thank you.
Thank you, Mr. Prime Minister. Thank you also for supporting this important event for the tech community in Kosovo. Keep in mind, there was a very important message by the Prime Minister, so make sure to contribute to open source projects ranging from Wikipedia to submitting a line of code and even to supporting the further developments, especially in the area of artificial intelligence lately. So next in line, I would invite dear Professor Ishaq Shabani, the Dean of the Faculty of Computer Engineering and Electrical. Welcome to the stage.
Good morning, everyone. Honorable Prime Minister of Republic of Kosovo, Mr. Albin Kurti, dear President of the Board of FLOSC, Besford, Mr. Besford Guri, dear colleagues from academia and industry, respected keynote speakers, innovators, dear students. It is my pleasure and honor as the Dean of the Faculty of Electrical and Computer Engineering and on behalf of University of Pristina to say all of you welcome to Freedom Kosovo Conference 2025. University of Pristina is the oldest and the largest public institution of higher education in Kosovo, which consists of 14 academic units, more than 30,000 students. The Faculty of Electrical and Computer Engineering is an integral part of University of Pristina. Currently, about 2,000 students are studying in all levels of study. Our faculty's vision is oriented toward the national and international model of contemporary and innovative faculty with integrated teaching, whereby practice complements theory and professional and research skills are developed for the benefit of society. Our faculty has gladly welcomed to join organization of this conference with FLOSC, and we have been blessed to provide our staff, students, as well as the facility and enrollment for our faculty for the organization of this important conference dedicated to the last trends in ICT. This year's jubilee edition marks not only a decade of the conference, but also 17 years of continuous impact in advancing open knowledge, innovation, and digital freedom in Kosovo and beyond. This conference is very important for all stakeholders of our country. A prestigious gathering of the brilliant minds and leading experts in the fields of ICT, as well, which have the opportunity to come in touch, build relationships with participants from academia and industry from all over the world. Nowadays, educational cooperation and economic development unite people and countries. Cooperate with university and ICT companies from different places are very welcome to our country, in particular to our faculty. I believe that this conference will deepen this cooperation. Therefore, I encourage you to share your knowledge and experience, collaborate, connect, transfer ideas into actions that shape a more open, inclusive, and innovative digital future. During these 2 days, we will hear from a diverse array of speakers, including keynote addresses from scientific and industry, technical citizens, showcasing cutting-edge researcher and interactive panel discussions. I would like to extend my sincere gratitude to the organized committee, technical committee, our partners, sponsors, and all volunteers who have worked tirelessly to make this event possible. Their dedication and hard work have been instrumental in bringing this conference to fruition. This conference is more than a gathering, it is a bridge between academia and industry, inspiring creativity, research, and entrepreneurship among the next generation of engineers and innovators. Thank you and enjoy this conference.
Thank you, Professor. Thank you also for a strong collaboration for many, many years with open source community. From day one, the FIEC University has been very close to FLOSSK and the open source community. And last but not least, I'd like to invite Mr. Besford Guri to give the final opening remarks, and then we move on with the show. All right, big applause.
Welcome, everybody. It's my pleasure presenting today the SFK, the 10th edition of the SFK. Thank you to the Prime Minister and the government of Kosovo for supporting this edition. Thank you to the Professor and Dean of FIEC. Can I have my slides, please? I prepared for you some small slides that will navigate and through the conference, and then so this year, the focus of the conference will be on AI, open hardware, and machine learning. We have different speakers that they will show you the scenarios and the tools that they build it. Today, we will open with the keynote David, which is unluckily not in Kosovo, but he will present online. And we will have Julian afterwards telling Arduino Uno Q, which is the new product just released. And then we will continue on Saturday as well with other topics that I will share the agenda later on. So this is a picture that shows when we started in 2009. So it's the 10th edition because some years we couldn't organize it. And we went to different places, but now we are back to FIEC. And I think that we will do the next year as well. But I want to tell you that on Sunday, during the closing ceremony, we will announce the month when the next SFK will happen. I want to thank all the partners, starting from the government of Kosovo, our academic partner, University of Pristina, our silver partners, which are Pretera, Incodex, and ProCredit Bank, bronze partners, 4Byte, OpenSUSE, Trembela, TomTom, Saibi, and Bbros, our media partners, Katrar, Telegrafi, Digitale, and LPI. So what will happen today, I shared a bit. We have two rooms with the workshops that I will tell later, but all the speeches will be here. The same thing will happen on Sunday as well. The workshops, go to the workshops. We have on room 1, it's in 440 number, that it's on that area. And then we have the other room, which is 414, that is in that space. But You can ask anytime and find the way to navigate. Some logistical aspects to share with you. We have all the day coffee that you can solve yourself on that area. When you see the workshops banners, then you know that this is the room for a workshop. They have the numbers as well, 2 and 1. We have plenty of booths. Please visit them, and as well, for anything, you can go to the registration and have more information if you need anything. So, thank you.
All right, this is what I like about the private community. So they show up to the stage, no notes, and they just wing it. So big applause for the opening speeches. Come on, let's bring the energy up. All right. So I hope the technicians are ready for the next one. So before, in the meantime, while they get started, I have a question for you. So who knows about Arduino? Raise your hand. Good. That's a good amount of number. Next question is, have you ever fried one, burned one? Excellent. That's amazing. So the next session by the co-founder and CTO of Arduino, an amazing keynote speaker, right? Who unfortunately couldn't come physically to Kosovo, but is going to hopefully join for Q&A session after the presentation, is going to talk about what we do when we burn technology. How can we make electronics composable? So technicians, if they're ready, then we can get started. I really like when we put them under the pressure and the spotlight. They're very stressed now. Technology is not working. It's working. All right. Audio?
Presenting 25. I would have liked to be with you today, but Arduino, where I'm one of the co-founders, like head of research, forced me to stop traveling, and also Malmö University, where I run I can be with you design master's program, as well. In the meantime, I'm really glad to be here to deliver this, where we work with the full representing. I'm also a member of the open Arduino, where I'm one of the co-founders and head of research currently, and also Malmö University, where I run the Interaction Design Master's program, as well as the Full Stack Lab Initiative, which is a lab where we work with the full stack for development. I'm also a member of the Open Source Academy. Hello, this is David Cuartielles, and I'm really honored to be here today to deliver this keynote for the FLOSS Kosovo 2025. I would have liked to be with you today, but my recent paternity has forced me to stop traveling for the forthcoming months. Hopefully, I can be with you next year. But in the meantime, I'm really glad to be here to deliver this speech, representing both Arduino, where I'm one of the co-founders and head of research currently, and also Malmö University, where I run the Interaction Design Master's program, as well as the Full Stack Lab Initiative, which is a lab where we work with the full stack for development. I'm also a member of the Open Source Academy of Europe, and if you happen to have any ideas about who to nominate for the Open Source Awards 2026 that will take place in Brussels just the week before the FOSDEM, please just let me know through any media, and I will be glad to bring up your nominations to the committee. Well, I work with interaction design, and what you see here is the cover of my doctoral thesis, where I analyze the use of different platforms as a way to work with technology, and how communities emerge around platforms. Arduino is one of those examples of a community that emerges around the platform. And interaction design is the name, and interaction design in general studies interaction between non-humans, which means persons and animals and plants and whatever other beings, and how these different beings communicate by means of digital artifacts, which is products and services. On a day-to-day basis, I work with things like what you see here, which is a system where I'm trying 3 single-board computers running Dev1, which is an open source operating system run on Debian, that allows me to run Phoronix on these single-board computers. This is part of a project that will bring the creation of the new family of Arduino professional boards that I will show you later. Also, the kind of things that I do include experimental systems where users can work with prototyping platforms in new ways. What you see here is the first experiment ever done with a phone running Bluetooth, an Android phone running Bluetooth with an Arduino board. In this case, it's a Bluetooth board that will allow you to connect sensors and actuators and have that information being controlled or represented on a phone. And at the same time, the touchscreen of the phone will allow you to control physical things connected to the board. We worked for several months, Andreas Joransson and myself, in building this platform. And after those months, we made a couple of workshops and documented it, and that's it. So many of the works I do are at academic level, are about creating new systems, trying them out, and documenting them. So I'm very interested in how people use platforms to learn and create things, and Arduino really falls into that category. In 2003, after spending several years teaching programming at Malmö University, I started teaching electronics to my students, and this was the first board I ever used to teach electronics to my students. And it's like in a microcontroller that used to be in the big socket on the bottom left. And in the front it looked like this, and on the back it looked like that. So students had to come to the lab, and they spent 12 hours more or less soldering all of these wires and making many mistakes, but it would end up working perfectly. And then they would build all sorts of different projects, like for example, an interactive chair that had two sensors, one sensor to detect movement around it, and one sensor to detect whether there was somebody sitting on it. And based on this, the board would respond to the environment, and if the chair was empty but detected a person around, it will call the person to sit on it, saying things like, "Hey, I'm lonely, come and sit on me." And when people who are sitting on it, it will praise them for being nice. "Oh, it's so great that you sit with me," and so on. But then after a couple of seconds, it will start flipping and saying like, "Hey, you know what? You've been sitting here for too long. What if you just left and leave me alone?" So the chair gives you the impression that there is somebody talking to you through a microphone, but everything for real is just recorded and uses a couple of sensors and gives this impression of somebody being in control. So electronics for me in class meant things like this. And I said this, as I told you, this prototype is from very early on, it's 2004, right? But trying to replicate the way we were teaching electronics, which became very successful, was complicated because of making these boards with so many wires. So we made the first Arduino board that was serially mounted, and you would build this board in 3 hours. But then we realized that people we were teaching, they typically had Macintosh computers, which didn't have serial port connectors like this one here. And just the converter USB to serial was so expensive that was more expensive than the actual Arduino board. So we started embedding everything from the factory, which made the whole board cheaper, more accessible, and the experience of starting much faster. And this is the Arduino Uno board, which is one of the most copied designs in the history of hardware, when not the most copied one. We've made it in the tens of millions, and we know there is other tens of millions copies out there from every country you can imagine. And an important aspect of this board is that it's open source, and we made it Creative Commons, because when we started with the Arduino project, the CERN open hardware license didn't exist yet. And so we decided that because the designs are human readable, the text, so the file format is actually human readable, it could be licensed under a Creative Commons license, like a book or a song. The only thing that is protected within the Arduino ecosystem is actually the logotype and the brand name. Okay, so over the years, we moved on to create boards like the ones you see here. This is Arduino Uno R4 that includes a chip from Renesas. After over 10 years making chips that were 8 bits, or using chips on boards that were 8 bits, we jumped into making boards that included Cortex M4 32-bit processors that's still working at 5 volts. To substitute those existing boards that have been with us for so long, but that require a revamp, and including things such as Wi-Fi and Bluetooth and USB-C connectors and so on. And so this is a new reference design for Arduino since like a year ago, and it's been very successful. On the other hand, we have other form factors like the Arduino Nano form factor, like you see here, which is very common to embed into smaller projects. This one runs on an ESP32, which is a quite famous and well-known chipset for Wi-Fi and Bluetooth. All of the Arduino content is contained into a single GitHub repository and is licensed also as a Creative Commons, so you're more than welcome to fork it and translate it to your own language and use it however you want to. Even the PDFs that are included in the Arduino website are rendered from this repository. So we have created scripts that will allow you to take plain text and YAML files and pack them together into a meaningful, easy to navigate and beautiful website. It has taken quite a bit of time, and this was an effort, collective for a lot of people, among others, Julian, who will deliver a lecture later. So, big kudos to Julian. Thank you for your work. And then there is also the Arduino IDE, which is a great piece of software, also running completely under GNU licenses. It's being divided into parts: the front end that is made in TypeScript, and the back end, which is called the Arduino CLI, which is a command line interface that allows you to do all of like the updates of the bits and pieces of the compiler, the front end, and so on and so forth. And the Arduino IDE itself has evolved quite a bit and is multilingual, so it's translated to a lot of languages, and that's our main contribution to the framework from the Eclipse Foundation that we used to create the Arduino IDE, because it was not multilingual. So the software is downloaded once every 2.5 seconds, and that's a pretty amazing record. So I'm really proud of this aspect, actually, that we can say our software is downloaded so many times. It means that it's successful. Of course, people say some people say that, oh, I'm a developer, my whole workflow is working on Visual Studio. But, that's great. I mean, there's nothing bad with that. So the Arduino IDE is great, especially for people who are starting or people who are making projects that don't require like a lot of branching of subfolders and so on, because it's designed to be very clean and very simple with a very simple structure and so. And also talking about libraries, there is thousands and thousands of libraries, and each library designer decides a different type of license for it. So we have created this website that you could check, docsarduino.cc/libraries, that contains the whole collection of libraries that have been contributed to Arduino, and you can then check their licenses, and you could filter them by licenses. You might say like, oh, I only want to have LGPL licenses so that I can hide the code to my customer or whatever. You're more than welcome to do that. So the Arduino core allows you to work with LGPL, so that it allows you to only show your code to whoever you want to, unlike the IDE itself. The IDE itself is GNU, so that's to be completely clear. So you will wonder what I was doing with those single board computers I was showing in the beginning, besides testing the processors with Phoronix and trying to figure out which one was performing the best. What I was trying to identify is which was the best microprocessor/microcontroller to run the Arduino Professional family of boards. So this is a microcontroller-based board. It's called the Arduino Portenta H7, and it runs on a Cortex M4 and Cortex M7 microcontroller, so it's dual core, and is financed through the Decode European Research Project. This work came out 2018, or at least the project was presented in 2016, 2018 around the day we brought it up.
Okay, this wouldn't be possible if it was a live session. Sorry for the interruption. We would like to thank the Prime Minister of Kosovo for attending the conference and the opening speeches, and also for supporting. They have a busy agenda, so we'll thank them for being present, and then we'll continue back with the slides. Yeah, resume where we were. Sorry.
2018, or at least the project was presented in 2016, 2018 around the day we brought it up. And it's been used mainly for industrially graded projects. Right now it's used quite a bit for space, like low orbit satellites, CubeSats and the like, because it's a very, very solid piece of hardware that has 160 pins on high density connectors on the back, so you can plug a lot of stuff to it. Among other things, you can run Doom. Doom is the de facto standard to check the speed of processors or microcontrollers. In this particular case, you see here the Arduino code that's needed to load Doom on top of the Arduino. If you're not familiar with this, the reason why Doom is used as a benchmark is because you only have to change a very small part of the code to make it render to whatever screen. So you can see Doom running on anything with a screen, actually. I didn't want to make a whole list, but it's a lot of devices. So summarizing, Arduino is basically a community of people that are interested in open source development of embedded tools. It's also a board, a collection of electronic boards. We have over 60 designs at Arduino. We don't just have the 8-bit Arduino Uno board. It's also an IDE that's downloaded very frequently, and it's open documentation, and it's also a company with 150 plus employees, sitting in many countries with offices in 4 countries. And personally, I'm sitting in the Swedish office based in Malmo. And as you know, actually, since very recently, Arduino has been acquired by Qualcomm, which is a pretty large company. And what you see here is our first project together, which actually making this project together inspired us to take a serious step towards merging. This is the first full computer of Arduino that can actually run. We have industrial computers, but are typically headless, so they don't run on the screen. But this one is a full computer. You can just plug it to a screen and a keyboard and run standalone, and runs Debian 13, has a microprocessor and a microcontroller that runs real-time operating systems such as like Sapphire. So yeah, this is 2 different modes of working: the standalone system or the PC-hosted mode, where you can, from a computer, choose applications you want to run. The applications are made of, for example, an AI that's going to run on a microprocessor, together with some software code that's going to run on a microcontroller, and that will feed the AI to do some stuff, and these things can be packed into applications that can be then delivered through an app market we have created to make it very simple. So if you need to prepare a class for your students, you might just want to prepare some apps for them to try out and then modify them and rerun them, and know how to make everything from scratch. Because now these hybrid systems start to be very complex. You start to have Python code, AI, maybe your own C code, and then suddenly the embedded code, and so on. And we've been thinking a lot about how to make this work. But Julian will talk more about this in his lecture. So I would like to show you some examples of things we did with Arduino. And I love to teach, and as a matter of fact, I continue to teach at Malmo University since many years. And currently, or recently, I was running this class where I was inviting the students to create their own sensors. And I don't know if you ever dismounted like a tactile switch, but the tactile switch is basically a piece of metal that when you press it, it changes its position, and then when you release it, it clicks back. And that shorts 2 pairs of pins, and that turns something on and off. And so it's so easy to make with cardboard and a piece of copper. So we teach the students how to do this kind of thing so they can make their own controllers. And in this way, we can demystify the complexity of sensors and actuators. That's just one example. So in a matter of morning workshop, 3 hours, people end up making their own controllers, and they end up playing computer games. Another example that you see here is a single line keyboard where my student Marcus, now no longer a student by the way, was trying to challenge us, saying like it should be possible to run a linear keyboard alphabetically ordered and should be faster than a QWERTY keyboard. And as you can see in the video, he's absolutely mistaken. And what you see here is the first ever made Arduino robot in 2005. A student from China made a multi-bit robot out of a kit from a Japanese company, and he controlled it through Bluetooth. In 2005, I want to tell you, we had no access to Bluetooth chips, but this guy had. And so he could make this design where through this wireless device, which is pre-mobile phone, because smartphones didn't exist in 2005, he could control this multi-bit robot. And you have to excuse his filming skills, but he's doing a lot of things at the same time. Here you can see it a bit better. Also talking about the community, I would like to briefly talk about Tim Barras, who is a software developer, punk musician, and currently living in a farm in Australia, who created the most used library for the production of sound and music instruments with Arduino. In this case, the library is called Mozzi, and here I have 2 examples. With Arduino made this single board that was called the Do Your Own Uno, and it consisted in a small computer where you could make your own device. It will be possible to like try out to make your own oscillators, but at the same time, with the same code, it's possible to make something like the following, which is a fully functional sequencer that runs on Arduino, which in this particular, this is one of the many examples. There's many like this one, but this one is particularly good, as you can hear in the with the music now. And then another example I want to show you is this one. This is a PhD student from Luleå University in Sweden, and he is working with a fuel distribution system for rockets. And he spent a year preparing the whole experiment, and here you see him flying the experiment on the zero gravity plane from the European Space Agency. And this is a moment that he's been waiting for a full year, like the moment when he presses the button and the experiment starts as he loses gravity, and the gravity is lost for like 10 seconds only. And this is running on Arduino Mega. So on the other hand, I would like to briefly talk about community-based form factors. And when it comes to hardware, at Arduino, we decided about some form factors that we think are relevant, but we can't cover everything because even though we would love to, the imagination of people is endless, and sometimes other things happen. And I would like give a big shout out to Leah Buckley, who at the time of making this board, she was a professor at MIT, and now she's in New Mexico in the United States. And she experimented a lot in creating wearable devices and PCBs made of fabric, and this kind of links to the end of my talk later on. And she made plenty of workshops and tried them out with people, and realized that a circular shape would be a good shape for the, let's say, core intelligence of a device that will be wearable. And she created a family of boards called Lilipad, and at some point Arduino carried those boards, and we licensed the name, so it was called the Lilipad Arduino, and it was manufactured by SparkFun, and you can still find it. Here you can see a bit of like the design process, and this was taken over by a lot of people working with crafts, and this brought electronics to yet another group of people. And so it shows how this idea of open sourcing something at some point can have a very interesting result several years later. This is a work by Becky Stern, which is very well known and has been featured at many different places on the internet. So, but there's also commercial devices, like for example Sony, who made the Sony smartwatch at some point. The software and UX office for this device is very close to us here in Malmo. So at some point they knocked our door and said, what if you try to hack the Sony smartwatch? They gave us some information about the header files of this device, and so just some days later we had this. So we could run Arduino code inside of the Sony smartwatch. There were people making games for it, there were people making small applications. Just to be completely fair, the only thing we couldn't fix was the Bluetooth, because they didn't give us access to the Bluetooth stack. Bluetooth is one of the most complicated parts, because the stack is not open, it's proprietary by many vendors and so on. So at some point in the late 2010s, we realized that making prototyping boards with just microcontrollers was not good enough, because more and more people want to do things that included sensors, but since you don't include the sensors from the beginning in the board, that compromises the size of the device, but it also compromises the price, because just putting sensors on pieces of PCB as single stuff makes it more expensive than embedding the sensors directly on the original device. At the same time, we wanted to have things that could support working with machine learning. So we created different boards, but just to give you an example, or two examples to be clear. The Arduino Nano BLE Sense, which has the nano form factor, has 6 sensors on board, among others, an N-axis accelerometer, like a Cortex-M4 processor, a microphone, a proximity sensor, and so on. Or the Arduino Nicla Vision on the right of the slide here, which is 2.5 times 2.5 centimeters big, that can run computer vision algorithms on a dual core Cortex-M4, Cortex-M7 system. So it's like a pretty powerful system that can do real-time machine learning, running MicroPython on one core, and then machine learning inference engine on the other core. In this case, you see a classifier separating between cans and bottles that's running directly on the board. This is a demo that is using the OpenMB development environment. So the new normal, in my opinion, is that new development boards will have to include developer affordances, which means making it easier for developers to work with them, including things as complex as Python or machine learning. But they also have to include some aspects of the craftsmanship that is needed to create other things, like different form factors and so on. We should include sensors and cameras and displays and be able of running machine learning. And we need to include battery connectors and make things low power, because they're going to need to be running on systems for quite a bit. So it's not the same thing thinking about prototyping in 2025 as it was in 2005. In 2005, just giving people access to the microcontroller was good enough. Nowadays, if you don't give them access to other things, it's not good enough. And it's very important to have these open source tool chains that would allow them to really, create code that could also be reused at other platforms. That's also super important. But let's look at the future. And in the future, we would like to make systems that are also more observant of the environment and sustainability issues. So I would like to bring up work that we are doing at the SCIRE4EU project, which is where the partners are, for example, Grenoble University, Budapest BME, or Leuven, among others. And there's Arduino, Machining, and other companies who are working towards creating new guidelines for designing electronic boards. And this is like the 5 steps of sustainable technology by ST Microelectronics. In this project, we are focusing on all of the steps, but mostly on creating designs that follow new design guidelines and how to manufacture them in scale. Because making biodegradable electronics, which is what we're looking at, can already be done in the lab. The question is, can it be done in the factory? That's what we're looking at here. In order to make them biodegradable, we cannot make the chips biodegradable. That's something we will take out. We cannot make the copper biodegradable. That's something we can reuse. What we have to make biodegradable is a substrate of the board. So here I have a board, you can see. It runs an Arduino Portenta X8, which is a headless computer running Yocto Linux, by the way. And this board is made of a mix of epoxy and glass fiber. The material is called FR4. And this is so durable; it lasts hundreds of years. It cannot be degraded by the environment easily. We're talking about microplastics being a problem, but electronics, this is also a big problem. So if we could get rid of the components and we could get rid of the copper, which can be done, what do we do with the substrate? So that's the challenge we're trying to address with this SCIRE4EU project. So we made this substrate made on PLA. As you know, PLA melts at 200 degrees, and this brings some challenges. But also PLA is a bit more brittle, and the grains of PLA are larger. So it's like if you compare, for example, MDF or let's say compare concrete with gravel. Concrete will be FR4, is very condensed and very fine grained, while gravel will be PLA. It's like a lot bigger, So this makes that when you got PLA on the side, this is a PLA electronic board. It looks like this. You can really see the grain. You see. But we have already made Arduino Nano on this new substrate. This is a biodegradable Arduino Nano, and this is a biodegradable Arduino Uno. So we can reach 1.27 millimeters pitch, which is pretty small, let's say pitch. But we cannot solder, for example, VGA. The granularity of the material doesn't allow us to do that. But we're looking forward to make a board that's going to be running machine learning, and it's going to be having LoRa as communication radio as part of this project. So please stay tuned, because in 2026, we'll be launching this board, and we will be launching a project throughout the second half of the year and the beginning of 2027, where we're looking at mass manufacturing these green boards, trying them out with people, and then collecting them back, extracting the components, taking out the copper, and recycling the substrate. So we have tried to make the full cycle at the factory level. But while we do that, we're already experimenting with composting the electronics. And to be completely fair, and if there is anybody who is an expert in this in the audience, you will have realized that PLA itself is not biodegradable. So we're just taking a first step towards a future biodegradable material, but we're looking at the challenges offered by PLA, which is just one step towards the real challenges offered by a fully biodegradable material. In this particular case, you see here how we are making both a laboratory test of etching a board through a chamber and also a composting test. And what you see on the bottom left is a picture sent to us by our colleagues at BME in Budapest of a first worm eating away an Arduino board. So the impact for the future is that we want to make truly recyclable and not just reusable electronics. So once you've been reusing electronics multiple times and they really come at the end of their lifespan, it would be great if we could repurpose the components, repurpose the copper, but give nature back the substrate. So in light of this, we're formulating two new principles. The first one is called cold manufacturing, and it's looking at the idea that in order to make these new types of electronics, you need to lower the temperature of the factory. Soldering typically happens at 350 degrees, but PLA melts at 200 degrees. So you have to solder at 120 degrees, 140 degrees. And this has been done in the lab already. It's perfectly possible. The boards you saw here, they're soldered at that temperature. The question is whether we can manufacture them in the factory. If we can really have a factory that works 24/7, where with half the temperature, it means that we're saving a lot of energy. That would be a great improvement globally. Then on the other hand, we like to talk about just enough technology. And it's the idea of having technology where when we have reached the quality and reliability we need at the user level, like let's say I have a computer, it already runs the software I need, why do I need to improve it? So if we make systems that are following this principle of just enough technology, we will enlarge the life of the devices. We will make them not just better, but we can also compete in making the components more durable, which will reduce the impact in the environment. So I'm looking forward to make some more research on this in the following 2 years. But guys, now that you know how it works, I just would like to invite you to make your own green boards. If you have any questions, just check out the Desire for EU project and stay tuned at Arduino's social channels. So thank you so much. I open the floor for any questions you might have. Thank you.
Okay, so I think
Hello, this is David.
we have David online as well on the call, right? So while the technicians are connecting, think of any question that you have in mind that you can ask directly. In the meantime, I would like to remind you that workshop starts from 11 on room 1 and 2. So if you have signed up for any of the workshops, make sure to follow the signs. One is over there, right? And the other room is further back. So one session is around FreeCAD for absolute beginners. So if you're into CAD drawings, beginner style, with open source, then please make sure to attend Joe Hinkleff's session. And the other one is AI literacy for non-technical people. Even if you're an absolute beginner, you can join that workshop session. Yeah. So yeah, this is just a nice reminder on these workshops happening in parallel to the main stage. In the meantime, waiting for the connection. David, can you hear us?
Hello, hello.
Perfect, I think you can hear us. Thank you for the virtual presentation. Can you hear us? Can you hear us? Test, 1, 2. No.
No, I don't hear you. Funny enough, I hear myself as echo. But oh, my echo is gone. But I don't hear you. But when you were playing the video earlier, I could hear the video.
So still no sound, you cannot hear us. Gör någon mikrofon. Hey, it's a open source conference, so technology happens. No pressure on the tech team. Test 1, 2. Can you hear? Test 1, 2. Unmute. Test 1, 2. Unmute the microphone. Testing. Can you hear? No. Okay, then maybe we move on with the next session, or. Okay, so yeah, we can type the question, we can wing it here, right? So apologies for the technical glitches. If you have questions, raise your hands, we'll type it down, right? So this is technology. So any questions, anyone in the audience? Yeah, you can type it down. You're cheating the system. Okay, those who are not hearing the question, they can see it written down there. And the question is, can you add other AI models for the UNO queue?
So what do you mean whether we can add other AI modes for the UNO queue? Like right now the UNO queue allows you to work with a full computer. So whatever you can do in a, and put into a Docker container, you can push it to the board on the microprocessor. On the other hand, the microcontroller could eventually also be running some code done for TinyML with a lot of constraints, but I mean, I'm not really sure that's an interesting option right now. So I think the microprocessor offers a pretty good way of working. If people are working whether you can do bare metal, I don't think we have a demo on that, but you can also talk to Julian, who is in the audience. Who has been already working with the UNO queue. He can definitely answer this question better than me at a more technical level.
All right. Yeah. Thank you, David. So yeah, we cannot do the communication. Yeah. Any more questions? Going once, going twice, going third. All right. Okay. Let's. Okay. So the question is, how does Arduino collaborate?
That's a good question. How Arduino cooperates with universities? Well, I'm the head of research, and I'm typically the one that is looking at working with universities and redirecting the efforts to different parts of the company. As examples, we have some collaborations with Politecnico di Torino, where some students are coming and either doing internships or there are some projects. We have some work with ITU in Copenhagen in Denmark, where we're looking at launching satellites. I had a meeting with the team yesterday. We had collaborations with Universidad del Valle de Guatemala, where Jose Baúl, one of our colleagues, is teaching, and he's also making the first and second satellites in Guatemala. You know, to the question, you know, more practical level, you should probably just send me an email and with a proposal, and then we see what we can do. We welcome proposals that are feasible and that could end up in an academic paper where some people in the company can collaborate. And we also welcome people that are willing to do European research projects that come with an idea and would like Arduino to be part of the consortium. We are right now in one very good consortium making this biodegradable electronics, but we have been in 5 different European projects in the past. So yeah, so we collaborate in many possible ways. but always you have to see some sort of an outcome. So just giving away boards is not the collaboration, that's giving away boards. Just to be completely clear. I hope I answered your question.
Thank you. All right. So I guess we can. One more question. Do we have a mic to send, or you can just shout? Oh, you have it right there. Okay. I guess this is the last question, right?
Okay, it's also a very interesting question, definitely. So AI, as you know, is impacting everything in different ways. One of the obvious and most simple impacts is that people don't want to type code anymore, and they ask ChatGPT, oh, how can I make a code in Arduino to connect a sensor? There's an ultrasound sensor, it's on pin 17, and how can the output be on pin 3 and be an LED? And they get a code. I find that a little bit useless because that program is so easy to make that what you should probably do is to learn how to program that and use ChatGPT for more complex things. On the other hand, there is the other aspect of how to create embedded AI, embedded machine learning. And that's something that we've been doing from the beginning. Arduino has been part of the process of bringing machine learning to microcontrollers. Well, to be clear, this has been done since many years ago, only that now it has been a very streamlined. So the first book on microcontrollers and machine learning from O'Reilly, for example, was based on the Arduino Nano VLE Sense. And the latest book that was forthcoming, but you can find it online, this machine learning for embedded from Harvard University, is using the NICLA Vision as the first example board. So the impact is huge because obviously we're looking at having processors that, while are still microcontrollers which are embedded, are meant to run with super low power, we look at them from the perspective they should also be able of running machine learning to some extent for making small nonlinear decision trees. So the impact is very big. But then how people are taking these things in, well, there's been several attempts, and I think the most successful is definitely bringing embedded machine learning into education in universities. That has been super successful. The question is whether there is projects coming up, for example, in the more commercial side, and that's something that is always very hard to know for us because companies don't tell you, oh, I used your boards for this power drill, for example, because they don't want to tell people what's their secret, right? But yeah, so we see there's a demand for it, and we have changed a lot of our tools to support machine learning in different parts. Like the old Arduino Uno R3, it could eventually run very basic embedded machine learning, but it's not powerful enough to do anything really interesting. But for example, the Nano VLE Sense is used in real-life applications. And we at Arduino have been collaborating with UNESCO's laboratory in Trieste, ICTP, the Institute for Theoretical Physics. And we've been teaching workshops about machine learning and embedded in different countries, and we've seen lots of interesting applications. So there is an interest, and people are willing to experiment, and the boards are allowed to experiment. So yeah, the impact has been very big. Okay. Yeah, well, we were participating in the development of like boards that would support LoRaWAN. We started with the Maker family of boards some years ago. We had every single protocol. So we had LoRa, LoRaWAN, we had Sigfox, we had Wi-Fi, Bluetooth, and so on and so forth. The Arduino with LoRa was not very much used by the community because they would find very cheap options by other vendors, and we couldn't make them cheaper, basically. But currently, in this desire for a U project that I was talking about in my video, we've been working with, or we're working with launching a board that runs LoRaWAN. So if you're interested, we are going to launch a series of biodegradable boards that can both do machine learning and communicate through LoRa. So the idea is to be able to building smart sensors. But yeah, we know people use Arduino a lot for LoRa-based projects because we see it in the Arduino cloud, but they don't necessarily use Arduino products to connect to the Arduino cloud. Yeah. As for using them together, as I said, you can use the cloud to do automations and connect to the Things Network to the cloud or things like that. Yeah, thank you so much, guys. As I said earlier, I'm sorry I couldn't be with you in person. It's for personal reasons, but as for next year, let's keep the possibility open. I would be really glad to come over and take over the space of Julian. But I hope you will have a great time with Julian. He has a lot to offer, and he really loves goats. Well, take care. See you soon.
Thank you. Nice. All right, we managed to wing that. So this is normal, happens when you have remote speakers. So without losing any time, I'd like to welcome with a big applause Julian to the stage. Come on, let's fire it up. So Julian is going to talk about UnoQ, an Android computer that dreams to be a computer. So, and he's going to do the first half of the presentation is going to be a demo, and then the second half is going to be more detailed presentation. So let's give it up for Julian.
Hello all, so nice to meet you today here, okay. I'm Julian Carolinares, I'm from Arduino Inc., and it's a real pleasure to be here today, to be honest. Today we are going to talk about two different things. First of all, we are going to present the new Arduino UnoQ, and we will have, some time just to make some questions, basically, and some real-time demos. Hopefully everything will go great, but technology. And after that, we will talk about the maker community and the open source community in another way, okay? So let's see, like the corporate talk will be right now, and after that, we will do some fun things that I think you are going to enjoy, okay? So, well, first of all, this is the new Arduino UnoQ, okay? And this board looks like just an Arduino Uno, right? Same form factor, same new matrix LID that we just put on the latest version, so you can be like Comet like, okay, and you can do nice animations, so nice projects, this kind of stuff. And you can do a lot of new things. So this looks like an Arduino Uno, but it's more than that, okay? So, first of all, we have a lot of different technical specifications. I'm pretty sure there are a lot of people here that are interested about exactly the microprocessor and microcontroller that we have here. But the most important idea here is just to understand that this is a dual brain board. And that means that we have a microcomputer, an MPU in this case, and a microcontroller that is going to be the STM32, okay? So here you can see that we have an amazing chipset that is called the Qualcomm Dragonwing QRB2210. Okay, we need to improve the names, by the way, okay? A lot of numbers, a lot of, doesn't sense. But Qualcomm Dragonwing, it's a really amazing chipset, okay? It's a computer itself, and this is the key part of this new Arduino Uno, okay? And in combination with that, you have a microcontroller, the STM32, as we already mentioned. So now we have a cool new ecosystem, and that ecosystem is intended to be used in parallel, okay? So we have a computer, a microcomputer running Linux, And at the same time, we have a microcontroller running C++, sketch of Arduino. And this is really cool. It's really, really, really cool, to be honest. Because of that, you can do multiple things. You can do, for example, let me show you some examples here, but you can do really advanced HAI things, as the Prime Minister was mentioning before. This is going to be really important in the following years. Basically, you can do from phrase detection to anomaly detection to see if a machine is not working well, to person classification, image classification, a lot of stuff. This Qualcomm chipset is really good at computer vision and also audio recognition. So I've been using it a lot of time. Hopefully I can show you guys today also in real time. And seriously, this chipset is perfect for computer vision tasks and audio tasks, okay? You are going to love it, and I'm going to show you how to use it in a really easy way. So basically, thanks to this dual brain, you can do new stuff in an Arduino. You can use it as a standalone computer or as a PC connected mode computer. And I think this is amazing, okay? That means that this little board, it's so versatile. And it's so versatile because you can use it as a normal Arduino. You just download the Arduino IDE, connect it to the Arduino IDE through your laptop, computer, whatever, and you can just program the microcontroller. But you can also download the new app that we call it Arduino App Lab, that we will see, and just program the computer part and the Arduino part all at the same time, okay? Just with the USB. So you can do Python, JavaScript, everything at the same time, plus the C++ of the Arduino sketches, okay? Everything at the same time. Let's imagine that you don't want to use your computer because you don't have your computer at this moment at the university, for example. You are bringing this in the backpack and you don't have a computer with you. Well, you can connect it to a keyboard, a mouse, and a screen, and you can use it as a normal computer and do the whole stuff, the whole prototyping that you need to, okay? This is the idea. This versatility is the idea of this project. And I think that is really, 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 really powerful. And you guys are going to enjoy it like a lot. Just to be quick, because I would like to show you some things in, live. All the new Arduino boards normally has this new connector. This is called the Qubit connector. This Qubit connector, if I'm not wrong, is from DigiKey or from SparkFun. Sorry if I'm wrong, okay? But it's a really common connector that you can connect different vendors and different modules from different vendors. And we created the modulinos, which are these kind of small sensors and actuators that you can connect it in a daisy chains together. And they are really easy to use, basically. So that is amazing, because with this, you can easily rapid prototype a lot of stuff, okay? The other day, for example, in Italy at Didacta, an educational event, we just created a study mode cell phone detector. So the camera was looking, just as the desktop of the study. Every time it detects an iPhone or a cell phone, just the whole modulinos start to gel and to blink, saying, hey, why are you checking Instagram again? You know what I mean? So you can do this kind of small but really smart task just in real time and just with just few clicks and some lines of code, which I think is amazing. I think you guys are guessing that if we have a microcomputer and a microcontroller at the same time, how we communicate between them? Well, they are internally communicated between them, and we created a small library that we will see that is called Bridge, okay? Bridge, it's a really easy to use library that allows you, from the Python point of view and Arduino point of view, just to share variables between both, both chipsets. And that is one of the keys of this new product. It's really easy to communicate between the computer and the microcontroller, okay? It's really transparent, let's call it that way, okay? So, okay, let's start. Let's do some crazy things here. Let's see what we can do, okay? So, first of all, I'm going to open Arduino App Lab. Let me see, where is my mouse? Yes, of course, here. Okay. So I'm going to open Arduino App Lab, which is here. Arduino App Lab. And here, okay, my double click now. Okay. So this is Arduino App Lab, and the first time you open Arduino App Lab, it asks you to connect one board. I'm going to connect this here. I'm going to connect it to my computer, and we are just to connect this board. This board now is starting to do this little animation, okay, of the Arduino logo. That means that the computer is loading at this moment, okay? It's doing the whole boot animation, okay? Once it ends, we will see a connected board, and we can start coding. Okay, here we are, just loading. Okay, and now it's connected, and we can start to code. So if I go here, you will see that the whole app opens, and you can see some of the samples that we have prepared for you guys. And these examples are multiple examples for different things. Some examples only use the Python part, and other examples also use the Arduino part. Other examples use both things, and they also add JavaScript because we have an interactive web page that does blah, 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 blah. So it's really powerful. And this is one of the reasons we created this new IDE, because with the normal Arduino IDE, it was impossible to program in Python or to program in other environments, okay? Let's put it that way. So the idea of Arduino Lab is to make everything together just in one program. So for the beginners, for the newbies, it's easy as, it's as easy as possible. Let's put it that way. Of course, and this is really important, and we will see it, this is a Linux Debian computer, okay? So the operating system is a normal Debian. You can just close or minimize this app, and you can use it as a normal computer, okay? No problem at all. Well, first of all, before making an example, let's talk about bricks. Okay, so bricks are this amazing thing that we just created that is that there are a lot of definitions and a lot of discussions about the definition, but a brick basically is a collection of resources that you can use in your project to do different things, okay? And they are categorized by the kind of applications that you can use. You can have bricks about database, for example, with SQL, which is boring in my opinion, but it's useful. You can have object detection, much exciting. So everything about computer CVE, YOLO networks, object detection in general, you have everything that you need, everything inside. Mood detection, camera code detection, auto classification. You can also connect to the Arduino cloud, okay, and see different things together, create web UIs in a very easy way so you can interact with your project. Well, you get the idea, right? That is the idea. At the end of the day, a brick is just a expanded library, let's put it that way. A collection of libraries, neural networks, and another stuff that can help you to do your project. So you just need to add that brick there, and it will install everything you need to do computer vision, for example. And that is so amazing in so many ways. Anyway, let's go to examples. And let's start with a really simple example, but in a new way. So, where we are, glass breaking, blah, blah, blah. Okay, so I have this example here that is called UnoQ pin toggle. And this example here is really interesting because of different reasons. First of all, since that this is a microcomputer, now we can add the documentation inside the microcomputer itself and inside the examples, okay? So every time you open a new project, the first thing that you will see, and developers are going to love that, is the README, okay? Of course, written in Markdown, no problem at all, with nice images and explanations about what is going on and what is happening, okay? This is so amazing. In this case, we are just creating, sorry about that, We are just creating an app. Okay. We are just creating an app that it controls all the GPIOs, okay, of the board just in real time. So this is an example. Let's run it. It's going to take some time, but there are some interesting things happening. So it's just adding all the libraries that it needs. It's adding those bricks, and in those bricks it's saying, oh, I need this thing from JavaScript. I need this thing from the Python part. I need to install this library to flash the board because blah, blah, blah. You need control of the GPIOs. So it's doing all of this right now in real time, and let's call it compiling, okay? But in reality, it's doing a lot of different things in the meantime, okay? So, you have an sketch, you have an Arduino program, I'm going to flash it on the board, and at the same time, it's installing the Python, okay, the Python libraries. Now, it's going to open a browser. Let's see what is here. Here we are, okay. And this browser allows us, inside this example, everything is local here, okay? This is the most important thing. It's offering this in a web server, in a local web server, okay? So now we can control the pins of the Arduino in real time, okay? We have a bunch of LEDs here, and we are going to control one of these, okay? So, if I click there, you can see that it's booting up. Sorry. And we can control in real time the whole board. Okay, we are changing the RGB, we can activate this one, etc., etc. Okay, let's load another project that I think you are going to love, okay? So, if I go, okay, here we are. Let's stop this up. And now, let's launch. Okay, we are going to do a little experiment, okay? Now, I'm using the board directly connected to my computer, and Arduino App Lab is running on my computer, okay? So this is a really valid way to work, and it's the easiest one, okay, when you're in a hurry and you want to develop. But Arduino Uno Q also can add as a single standalone computer. And we are going to do that experiment there, okay? So, I'm going to disconnect the thing. I'm going to disconnect also this one. And I'm going to connect it to the Arduino Uno Q. Let me just put it this way. I have my USB Type-C hub, and this is the most important thing, guys. Thanks to the interface of the Type-C, you can just connect everything to the USB Type-C hub, and you can have the image, you can have the sound, you can have the computer, the keyboard, whatever you need to, including webcams, for example, okay? So, I'm going to connect the SDMI here, and I'm going to connect the whole thing to the Arduino Uno Q, okay? So, now it's powering, and in some seconds, we should start to see the boot signal, okay, of the board. Let's see. Fingers crossed. Okay. And there we are. Okay, cool. Yeah, that happens. And the key part here is that I have a keyboard and a mouse, okay? So now we are using it as a single board computer, which is fine. This is amazing for universities, in my opinion, because you can just buy this board at the beginning of your career, let's call it that way, okay, the first year. Just the calculator, right? The first calculator that you buy, and it's going to be with you for a lot of years. And it's going to serve you in a lot of ways, okay? Including that one that we already mentioned about how to, when I don't have the computer because I forget it, I can just to connect my Arduino to one of the monitors and just work with it, okay? That is the idea. So, where we are? Oh, what happens there? I think we lose the signal, sorry, my bad. Let's put it again. We have some minutes, so let's put it again. Okay, yes, we still have some minutes. Let's put it. And let's see if I can show you some of the samples in a standalone mode, okay? One of the important things is that maybe we have some problems with the Wi-Fi. That will be okay. But yeah, let's try it. Okay, we are booting up. Here we are. The password in this case is Arduino, okay? In case you need it, Arduino. Here we go. We are loading up, and you can see that once you open the operating system, Arduino App Lab just open automatically, okay, for the newbies, but we can just minimize the whole thing, and we have a Debian distribution, okay? You can open the terminal, you can use whatever you want to. It's a normal computer with a Debian Linux Debian distribution, okay? So let's open Arduino App Lab, and let's try, let's see, because Wi-Fi sometimes is tricky in this kind of public places, but let's try to do a face detector on camera, okay? Let's see if it works together. If not, we will see. So I connected just a webcam to the whole thing, okay? In this case, an Intel RealSense, you know, use it a lot in robotics. And I'm just going to run the example, and let's see what is going on. Okay. Let's load the whole thing. Okay, so we have some problems with the dependencies, which is okay. This is due to some internet connections, but that is okay. And we are just going to show you guys some interesting things. So instead of that, we are going to open the weather forecast on the LIT matrix. What is this? So this example, as you can see, this is the normal project of an Arduino App Lab thing. And you have the Python thing and the Sketch thing. Here you have our Python program, and here we have our Arduino Uno program. Okay, this project basically takes the weather from the internet and put in a really nice animation of the LED screen what is the weather like, okay? So you just live in your room, whatever, and it shows the sun, raining, whatever. This is the idea, okay? How do we do that communication between the Python and the Arduino part? Okay, we do it with that library that we call it the Arduino Bridge. And if we go to the Python part, you will see that we have this line of code here that is called Bridge. And you have Bridge provide, I know it's so small, sorry. Yeah, you have Bridge provide, get a weather forecast, and we are just sharing a variable, okay, that the other part is receiving. So in the sketch of Arduino, you have a lot of different things, and you have also this line, which is called bool, okay, bridge call, and it's first of all sharing what is the city, and second, receiving what is the weather, okay? This is the idea. So I'm going to change the city. We are going to put, no, I'm going to, you know, Arduino is located in Turin. I'm from there. And I would like to know the weather at this moment in Turin. So we are going to run that. Now, as I say, it's loading the whole thing, okay? So it's loading the Python part. is loading the brick, that is the API that allows you to do very simple API calls. It's flashing the part of the animations of the LID screen. By the way, the LID screen is one of the most interesting things that you can see, basically, because it allows you to just show really good information in just seconds. In the meantime, while it's loading, I'm going to show you guys that we just created a new kind of connectors in the back of the board that is called high-speed connectors, let's call it that way, okay? And there we put all the high-speed interface, like audio, vision, a bunch of GPIOs from the microcontroller, a bunch of GPIOs from the microcomputer, the whole thing. Here we are, okay? In this case, we don't have a graphical interface, but you can see, because it's Turing, okay, that is cloudy. It's not raining, but it's cloudy, okay? And that is really cool. Now you can connect it to, to your fridge, in some of the tables of your home, and it's going to work continuously, showing you the time in real time, okay? Yeah, more or less, that is all. I highly suggest you guys, once you have one of the boards or you see some YouTube videos, to see also the computer vision's possibilities of the board, because they are amazing. As I already say, this Qualcomm chipset is really good doing computer vision and audio classification. So I highly suggest to take a look at that. And I think we have like a couple of minutes to do some questions. So if you have any questions, please tell me.
Okay, we start from here and then we...
Thank you very much for your interesting presentation. Let's assume that university would like to use this approach. How much will cost, let's say, a small lab that we can put in a pocket or a suitcase that the teacher, professor, the tutor can have it and bring it? Let's say, how much will be this for university?
Yeah, so of course, in education we have, different package and the whole thing, but the most interesting thing is like the retail price, let's call it that way, for the 2 gigabytes version is just $40 or 40 euros plus VAT in general, so around 47 depending on the country. Okay, I should ask the Prime Minister before, like, what is the VAT, the actual VAT here, right? So that is the 2 gigabyte version, so around less than $50, 50 euros. And the 4 gigabytes version will be $10, $12 more, okay? So 60 something, okay? That is the idea. In every of the cases, with the whole thing, USB hub and power source or whatever, less than $70 to have a student, okay, already prepared and equipped with this. I'm really excited about this new board in the educational segment, not only universities, but I think universities can use a lot this board, because I really would love to have something like that when I was studying robotics engineering, long time ago, just in my backpack. So every time I need to create something new, I need a computer or I need a microcontroller, is there, So yeah, it's like $40 Euros plus VAT, 2 gigabyte version, 4 gigabyte version, 10 euros, 12 euros more, okay? That is the idea.
Mr. Julian, thank you very much for your presentation. What about the backward compatibility with the previous projects made in earlier boards? Do users need to install both of them, or they can just switch to the new one?
In which sense? Sorry, I don't understand.
Whatever they have prepared earlier project done with earlier boards, now if they switch to the new board, UnoQ, what will happen?
With the compatibility of the new the ecosystem in general. Okay, yeah. First of all, in Arduino, you know that Arduino was acquired by Qualcomm 2-3 weeks ago, okay? And this is one of the questions that the community, including myself as a maker, is asking themselves, okay? What is going to happen in general? So, the idea that Qualcomm acquired Arduino is to access to the open source community and learn from the community, okay? Arduino is interested about the 30 million developers that the Arduino and the Maker community is putting there. And the only interest of the acquisition is to make sure they understand the community, and also they show the community the amazing technology that they are creating. So they know, they are aware that they are really good, they are amazing, creating technology, but they need companies like Arduino or Foundries or, Edge Impulse to explain to the community how amazing that technology is. So for a compatibility and also networking point of view, everything is going to remain the same from that point of view. Everything is open source, including this new product. Everything is open source. All the programs that I show you, all the samples that I show you, the schematics, everything is there on docs.arduino.cc, and everything is open, which means that if something is not compatible, it's because we didn't have enough time. So if you guys as a community can help us, that will be amazing. Okay, that is the general idea.
When can I get one?
Sorry?
When can I get one?
Okay, yeah. So basically, you can already acquire one of the boards. We are already shipping on the boards, and 2 days ago, the first users were already receiving the boards. So basically, if you acquire it right now, we are creating stock all the time, okay, as crazy. In probably 1 week, 2 weeks, you will receive your new board. So, yeah.
Thank you for your great presentation. I have 2 questions. One of them is, if we are comparing this product with Raspberry Pi and let's say Omega, what are a pro more than other similar use cases? And another thing is, I want to know regarding the over-the-air update, do you support the over-the-air, and what kind of, let's say, a restriction you have if you want to do something like that? Let's assume that I want to create something like any play-out supported project or something like that. How can we establish over-the-air on this device?
Okay.
Thank you.
Yeah. Well, first question. What is the power? First of all, you need to take into account that there are different architectures, okay? This is for the real nerds. So there are different architectures, so we can compare, but it's not going to be exactly the same, okay? While some versions of Raspberry Pi can be better in some of the things, the Arduino Uno Q will be better in another things. Some users are starting to do comparisons, and at the end of the day, this is the conclusion. Like, depending on your application, this is better or this is worse, okay? In that case, if we do this unfair comparison, it will be like a Raspberry Pi 4, more or less, okay? Cool thing, thermal design. This chipset, this SOM, is really good managing the thermal thing. We don't need a dissipator, we don't need a fan, we don't need nothing, okay? We have been using this for hours during the latest weeks in different fairs, like Maker Faire Rome, and you don't need to put nothing, okay? It's okay from a thermal point of view. So that is the idea of the power. The second question was about OTAs, right, in general? Yeah. Yeah, how we can implement OTAs. Well, first of all, Arduino. We are Arduino. We provide you the tool. We try to provide you as many tools as possible. If it's not there, you can ask us, or you can start to coding yourself, okay? In this case, yeah, it is. In this case, we have the full Linux system and also the full microcontroller system. And you have the challenge of doing an OTA for the Linux, but also for the microcontroller part. We have a tool that is called Arduino CLI that you can use to do that thing without any issues inside the microcomputer part, okay? So from the microcomputer, you can compile and upload to the microcontroller everything in real time. No problem at all. Indeed, Arduino App Lab is using that. So you can create it yourself with your own OTA system, but part of this acquisition with Qualcomm was to acquire Edge Impulse, really good creating neural networks, Arduino, of course, and Foundries. Foundries is one of our colleagues, our companies, okay? Companies colleagues, and they are really good creating OTAs for Linux embedded systems. So probably in the future we will have a solution from Foundries, okay, to do it in a really massive industrial way, okay?
Thank you for your very nice presentation. You mentioned mood detection.
Yeah.
And I'm curious to know, does this model analyze only the face recognition like Mimic or other sources of like temperature or?
Yeah, so in that case, we are going to disconnect this. In that case, if I'm not wrong, we are using YOLO, the YOLO network, plus another network about mood detection, okay? As a robotics engineer, I don't know what is the latest state of the art in the latest year, but I can tell you that mood detection is always challenging. I guess that is the question, okay? But the whole recognition part of the face detection and Face ID, which are different things, is working really well. And the mood detection, you need to play with the thresholds. In any of the cases, we are using networks like YOLO to do mood detection and to do another stuff. So they are the open source tool that the whole community of the researchers are using there. You know, if we have new versions, we will put those new versions with edge inputs there. So a newbie, a person that doesn't know a lot of technology that is using an Arduino Uno Q, always will have the latest technology, the latest top-notch state-of-the-art technology updated there, okay? So yeah, it's working well. I'm not complaining, you know, but mood, it's a really challenging part. We can talk later if you want to about how to implement it. Thanks.
First, thank you for the presentation. I would like to ask you something more technically maybe. Can we integrate Arduino with GSM modules, for example, to send and receive messages in real time using WebSockets?
Yes, I mean, 100% of the times that I'm receiving technical questions to use an Arduino, the answer is yes, okay? We just need your talent there to do it. From a technical point of view, hardware point of view, absolutely yes. But it will depend on the hardware that you are connecting, how you are connecting the hardware, and the whole thing. You have some commercial things that you can just connect to the microcomputer and decide what to do with that, and you will have more embedded system things that you can connect to the pinouts, okay? And just start coding in C++, so Arduino, and receive the data. But yes, you have that flexibility, no problem at all.
Thank you.
Yeah.
All right, yep. Julian, you got some really great question coming to you.
Hello, Julian. Thank you for your presentation. It was clear and informative. I have a question related to Arduino IDE, the old way, and Arduino Uno Q. I'm not sure if you hear that. Between Arduino IDE and Arduino Uno Q, what's the key feature that you can like summarize in terms of pro and cons between these two? Also, since this Arduino Uno Q has a lot of benefits directly on the prototyping, like using Python languages to get as fast as possible on coding, in terms of performance of RAM and processing power, what's the difference between Arduino Uno Q and Arduino Uno, the old way?
Okay, yeah. So let's start with the latest question. In terms of performance and processing power, you have an amazing STM-EU microcontroller in the Arduino Uno Q, and it's top notch. So you know, it's I would say in some things it's even better than Arduino Uno R4 microcontroller that we have from Renesas. Okay, so you can do that comparison, but at the same time you have the microcomputer on the other part. Okay, just to be aware of. The other question was, yeah, what is the difference between the Arduino IDE and Arduino AppLab? So with Arduino IDE has been used by millions of developers across the world, but it's also focused on the microcontroller part, and that is amazing. There is a reason why the Arduino IDE is still as simple, okay? Some developers complain about, no, but this is really simple, I prefer VS Code. That is more than okay, then use VS Code, there is no problem at all. But the Arduino IDE must remain the simple thing for entry-level people that is starting to program on microcontrollers. So the main idea is Arduino IDE is only to program microcontrollers. So in case we are starting at the school, for example, and they are learning C++ for the first time, they can use just the Uno Q as a normal microcontroller and forget the computer part connected to the Arduino IDE, and that is all, and that is more than okay. And in the future, when they will start to do some Edge AI complex problems, they will open the Arduino AppLab and they will start to add Python, computer vision, the whole thing. So there are the main difference, okay? Pros and cons, obviously, if you are using Arduino AppLab, it's a very easy to use app, but if you are an absolutely beginner in all the ways, okay, maybe you should start with the Arduino IDE, learn a little bit about microcontrollers, and after that, jump to AppLab.
Perfect, all right. I think that's it. And one more final question.
I really like the feature where you communicate between the processor and the microcontroller. Does that also support the other microcontrollers? So if I want to add another board to connect with the new Arduino?
Okay, this is so exciting because we already have people that is trying to create their own board, which I think is something that I love it. I need to double check. In theory, everything is open source, okay? So if you mimic, the interface or you add additional code to the actual library, it should work, okay? This RCP library, because the bridge is that, it's an RCP library, will work with the new hardware. Maybe we will need, to add more lines of code and we need to see the new interface, but absolutely, it's absolutely open source, you can do it, okay? Yeah.
Okay, thank you very much. Big applause. All right, some really great questions we got from the audience, and which is a nice gateway to your next next session, right?
Yeah.
Yeah? We're good to go? We can continue. We can continue because there's going to be lunch break and everything.
Now I'm
so
going to
let's
change. I'm going to change plan. Okay, so give me just a minute to.
All right. So in the meantime, while we have the technical setup from Tim Julian, remember we have food for everyone. So lunch will be free, as in free software as well. After the final session from Julian. In the meantime, there are workshops going on. There's also a couple of booths that you can visit. And also, there's going to be a task for you during the break. Try to meet some new people that you haven't spoke to before. So try to talk to at least 2 new faces during the event. Now I remember why David mentioned that you like goats.
Okay. Sorry, I need to add my new toys. Okay, here. So be patient. I'm going to hide the Arduino Uno Q here, okay, in case you want to. This is a zip. Thank you. Okay, don't worry. We will figure it out later. And yeah, I think we are almost there, okay? So, there is a reason of all of this, okay? Don't worry. I swear that there is a reason of all of this, don't worry. Okay, this is one, and this is the other one. Okay, cool. Cool. We are going to put this little guy here, and we are going to start to talk about that, okay? Yeppa, and this is another example. Okay. So.
All right. Big applause again for Julian. Come on.
So, welcome to the more maker personal talk that I'm going to do today, okay? Working in a company like Arduino and being a maker, especially in Spain for a long time, made me reflect during the latest years about a lot of things, and this talk is about that, okay? So, play like a god, the importance of creating silly projects, okay? Well, first of all, I present already myself. I'm Julian Carolinares. I'm an electronics engineer, robotics engineer. I've been working in a lot of places. I've been a robotics freelancer, blah, blah, blah. And in the latest years, I've been working in Arduino, first as the team leader of the content team, and in the latest months as Arduino Tech Evangelist, okay? So I have the opportunity to go here, explain you guys things, create new demos, this kind of stuff. This is not important, okay? The important part here is that I consider myself a maker. And this is one of the most important parts that you guys need to understand. You can have an amazing CV, you can talk about a lot of things, but at the end of the day, we are humans, and humans are all about connections. And the maker community understands a lot about that. So, the goat. Why I'm talking about the goat and why I've been so obsessed about goats during the latest years? Well, there is a really strong reason. And that reason, this goat, is the following one. So this is Slack. I don't know if you guys know Slack, if you use Slack. This is this corporate thing, you know, just to send messages, the WhatsApp of corporate, where you can talk with your colleagues, really useful, you can sing, you can do a lot of stuff. Some years ago, I was in a really boring meeting, okay? And we were just attending, and I was in the meantime doing a little chat with one of my colleagues, Katerina, and she was telling me, hey man, yes, blah, 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 this kind of stuff, you know, our life. And at some point, she told me, hey, I just bought this thing from Amazon. I think it's amazing, okay? Because she's like me, she loves this kind of silly things, okay? And I was like, oh, you know what? And she was like, what happened? You know what? You know that moment of Eureka moment? I was like, yes. And he's like, Katerina, we are working in Arduino. And he's like, yeah, I don't understand. And he's like, we can hack this, okay? And this is the thing I did, okay? So I ordered one to Amazon. I ordered one from Amazon. This is just a small commercial product, okay? Really nice one that you can buy on Amazon, okay? And when you press it, let's see if it works. When you press it, okay, you can feel it a little bit, I think? Yes, okay? It's a screaming, which is interesting, okay? It's fun, it's a screaming. You know, goats are fun things. And it was like, yeah, we can hack this. So we decided to hack it. Well, this is the whole conversation, of course. We decided to hack it. And this is the unofficial Arduino Go project, okay? Totally unofficial. The boss don't know nothing about this. But basically, this is the first photos when I hacked it for the first time. I opened it. I discovered that PCB there, you know, with that button. And I discovered there, I will so point it to you, that little test point. This one there, okay. And that little test point, it's amazing because it has access directly to the button and to the microcontroller signal that is going to make the, okay, Go gel, basically. So I say, okay, yes, this is possible, this is possible, this is possible. I was so excited, you know, that Eureka moment, like, yeah, I can do this, I totally can do this. And after some, you know, tests with a multimeter, the whole thing, I have my first Eureka moment, it worked, it starts gelling, okay? And I say, okay, then let's connect an Arduino Nano, and we can control it, okay? What is the cool thing? Today I don't have it because, you know, Wi-Fi connections and the whole thing, but we have this thing in Arduino that is called Arduino Cloud. And with Arduino Cloud, you can create your projects online, and you can also have a dashboard online that is synchronized with your little project. And Arduino Cloud has an amazing feature, which is to share variables between projects. So I can have a goat connected to another goat, connected to another goat, connected to another goat, connected, you get it, okay? You get it. So, as you can see there, those are my colleagues from Malmo buying like, I don't remember, like 10 goats new, okay? And I start to hack them, okay? We did a small workshop and we start to hack them. And we just put just 2 DuPont cables, 2 jumper wires, okay? Of ground and that signal. And we just connect it to the Arduino, connected to the cloud, and all the goals right now are synchronized, okay? I don't have this cloud connected, but basically we have a network of 15 goals, something like that, that are connected between Turing and Malmo office. So every time David Quartelles called people to launch, okay, they use the goat, and all the goats yell, okay, including at home, okay, my home. So yeah, it's a really stupid project, a really simple one, but it's a project that we enjoy it so much, and we still use, and we still develop, okay? That is the point. So, of course, I decided when I was invited by the organizers of this amazing conference, I saw, you know, the marketing, I saw the amazing t-shirts that you guys created, and the phrase, do Andon dreams, you know, the Blade Runner thing, Philip Dick, and I decided, okay, we should create a SIP version of this, okay? So this company is not only selling goats, it's also selling SIPs, okay? They have been improving, okay? I opened the hardware the board now is better, you know, it's more professional. They decided that the button was not good enough, so they created just a simple pass button there. You know, they are improving. They are really impressive. You can separate the sheep, you know, from the goat, which is also amazing, okay? And yeah, basically you can see the PCB there, and you can see that there is also a test point. That was my, you know, my fear, like some weeks ago, that you can always connect, okay, to the whole thing and to the speaker. That is my desktop, my Maker desktop, and we'll start a screen, okay? Today I don't have the connection, I don't have it done with the Wi-Fi thing connected to the Wi-Fi, but I'm just using my Flipper Zero, okay, to control the GPIs of the Flipper Zero and put the signal. So, okay, this is the official Arduino Floss Kosovo, okay, chip. Indeed, it's a small gift to you guys. So, if you can take it, that would be great. Thanks. Take it, Joe. Okay, this is for you guys. Thank you for the event. I can't wait to see the things that you can connect there. Okay, but the question about this thing that I just told you, okay, like, okay, conclusion, this guy is crazy, we already know that, it's okay. But the question when I created with my colleagues this project for the first time was, man, in theory I'm an electronic engineer, robotics engineer, I have some experience doing really nice and complex projects. Why are wasting my time doing a goat cloud connected that gels in synchrony with another goats? Like, it was like, also I received some, you know, message from family and friends like, yes, it's okay, but what are you doing with your life, you know? And it's like, no, it's fun, you know? And that raised this question and this talk, like, why? Why are we doing this kind of silly projects? Anyone? Any idea? Okay, I will try to answer to that question in the next slides, but we have some amazing examples, okay? First of all, you are not a robot, you are a human. You don't need to justify what are you doing to other people, okay? Pay your taxes, please, and don't kill anyone. But yeah, apart from that, okay, you don't need to justify what are you doing with your free time, especially, okay? But I started to ask to the Maker community, okay? What is the most silliest project that you have made ever, okay? And some of the answers, this is in Spanish and it's so small, but I will try to translate it. This answer was amazing. It was like, okay, so I created a controller that is working via Bluetooth to the PC, connected to using Bluetooth to the PC. It's managing a web browser using Wi-Fi with the ESP8266 that transmits the values in JavaScript. I don't know why JavaScript to this, okay? And those values of JavaScript are transmitted to the 80 mega microcontroller that is controlled by that hard disk. For some reason, there is a hard disk, okay? The answer, you know, the thing that shocks me was the final answer of the twist, okay? In Spanish, porque sí means because why not? Because yes, okay, why not? And that was part of the question, you know? That was part of the answer of this question. We can do things just because we would like to experiment and play. And this is a really important part of this process. Because I can, this is the answer, this is the first answer, okay? This is the first answer that you are going to answer your family and your friends if you're a maker. Like, this is already invented. Why are you doing this? Because I can, okay? It was fun, I don't know, I was obsessed with this thing for the latest weeks, you know, yeah, I know, but because I can. And that because I can, it's really important in the technology sector. Because, well, you know Doom, right? Yeah, there is a lot of young people here. Probably young people doesn't know what is the original Doom, okay? They are playing like the good ones, modern ones, but the original Doom was released a long time ago, and after a year, they released the whole source code of the Doom thing. And that was amazing because it was like a similar strategy like Arduino. And in that case, you can practically put Doom in every machine that you can imagine because you can compile it yourself to that specific platform. Why? Because you have the source code, okay? And this is amazing. People has been putting Doom on a pregnant tester. I don't know why a pregnant tester has a microcontroller. An ATM, a multimeter, let's call it that way, a calculator, the CPU, Windows Manager, and even a smartwatch, okay? And this raises another answer, because it's possible. And if it's possible, we are humans. If we have a button that says, do not push, we are going to push it, okay? So, first of all, we need to test it. And after that, we will decide what to do with that. But first of all, I need to push that button and discover what is going on. When we are young people, you know, we are newbies, we love to push new buttons and, you know, test the world. That is the idea. This has been already invented, and this is a really important thing, okay? When I was young, my father, because he loves to tell me, you know, I was showing him, you know, my Lego projects, my amazing new camera made from Lego, different things. And he always told me, you know, just to tell me, just to pick me up. Oh, but this is already invented, you know. And I was getting mad like, yes, but my version does blah, 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 and it's so fun and it's so amazing. And he's like, yeah, but it's already invented, no? We should create something new, okay? Obviously, he was joking, but this is a really important part of this process. And that really important part is, let's put the battery out, okay. That really important part is this commercial from Lego of lot of years ago, the 90s, okay? You can see the commercial. I think the commercial is so powerful, okay? And basically shows this little girl showing his house thing and says what it is beautiful, okay? So some of you have child, and you can imagine, you know, during the age of they are starting to grow, they are showing you a drawing that is like, you don't know what is that, okay? But it's beautiful. Why it is beautiful? Because it's part of their discovery process. And that discovery process, sometimes we lose it when we are adults, or we think we lost it, and we don't want to recover it, but it's still there, okay? So we need to be that girl. And basically that girl is a maker. And makers, when we are in this kind of events, showing projects to other people, we are doing exactly the same as her, okay? Because we are proud and we think this is, you know, fun. So the point is, hey, I created this amazing thing. Maybe you don't care, but I think it's amazing. So I'm going to share it with others, and other people will find it interesting, will say suggestions, will start to talk with me. And that is the point, okay? So every time as a maker you create a new project and you want to share it, please share it because it's worth it. It's always worth it. You're that little girl there, you know, just showing your crazy thing and just showing a little part of yourself. And that answers almost the whole question, you know. We create projects because we can, because it's amazing, and we share it with others because it's a way of expressing ourselves. And this is so important. I'm going to show you guys some little samples of crazy projects that I've seen through the years, okay? This is actually a research project of the university. Sorry about the quotations, citations, I didn't put it, my bad. But basically, it's a robotics exoskeleton for a snake, okay? I don't know why, but this researcher was like, snakes are cool, right? But wouldn't it be cooler if we put legs on snakes? And nobody say, no, you didn't get it, okay? The cool things about a snake is like they don't have legs, okay? So they're starting prototyping, and they created this thing, okay, where they put the snake inside, and with some cameras and some sensors, the snake can control its new body, okay? From a researching point of view, it's amazing. Basic science works this way. Let's figure it out, let's test it, let's arrive to new things, And after that, engineers will discover probably what to do with that, okay? But basic science should work that way, should have that child decide of experiment and see what is going on. This is really interesting. Do you know Goya, the famous Spanish painter? Okay, yeah. Goya, you can see most of its, art in the Museo del Prado in Madrid. Goya is amazing in so many ways, and if you go to the Museo del Prado, you will see like 2 different floors for Goya. Sorry. The first floor is this one with Goya and, normal painting. But that is also Goya. This is Goya, Saturo devorando a sus hijos, okay? Which means Goya, this painting is Saturno eating their siblings, okay? And yeah, it's a table paint, okay? But a really interesting one. Why? Because you have an artist that changes style from there to there. No single AI is able to reproduce that, okay? In the sense of, if you ask an AI about create a Goya paint, okay, or a Picasso paint, they will take all the Goya's paintings and they will create an average painting. But they cannot understand that Goya is a human, and at some point of his life, he needs to create that, okay? And that raised a lot of questions to me. We are doing somehow the same, okay? Goya there was like mastering the rules, and after that, breaking the rules to create new things, just as Picasso. And in this case, in the RepRap movement, we do the same thing. We did the same thing. We took the actual technology from the industry, and we break those rules to create a new project, an open source project, which is, the origin of the whole amazing 3D printers that we have right now, okay, for the market. FPGA Works, open source FPGA, is another project that follow the same rules. I highly recommend to take a look because it's really interesting. And well, you have a lot of examples. The original Tetris, the history is amazing, okay, involving the Soviet Union, Nintendo. Interesting. The famous grants, okay, we sell just to hack the telephone lines. And of course, the first video game, okay? The important thing here is the following. Technology, at the end of the day, changes the way we express ourselves, okay? And it's more related to art than we normally think, okay? People that normally is maker, they came from different backgrounds, but the people that came from the engineering background like myself, we normally think that we are not artist people, that we are not good expressing ourselves. And I think it's not true, and it's unfair. We are expressing ourselves in another way, okay? We are expressing ourselves with our own tools, and this is the most important part, okay? Another example that I love to explain. When photography was invented, artists were shocked. Like, what are we going to do? We were doing this kind of paintings, just to try to recreate the world, and now you can just take a photograph, and I cannot compete with that. It doesn't have any sense. I'm not going to do this kind of thing when I can take a photograph, okay? I'm not going to represent the world anymore. And they discovered that they could represent the world, the internal world of the humans, okay? This is El Guernica. Do you know Guernica? Sorry about the Spanish reference, but, I'm in Spanish. Guernica was this town in País Vasco that was bombed by the Nazis, basically during the Spanish Civil War, just before the Second War, and they bombed it was one of the first bombing against citizens, okay, in the whole Europe, and they destroyed the whole city, and they killed like a lot of people, okay, basically. And this become, you know, a real terrible event in the whole Europe. And Picasso prepared this painting, okay, which is called, of course, El Guernica, that you already know and that you can find at the Reina Sofia. Interesting thing here, this is a photograph of the actual Guernica after the bombing, and this is Picasso representation of that. Styles, totally different, right? So, with technology, it's happening the same thing. Sometimes we discovered that some things that we were doing were really interesting, and at some point technology advanced so much that nobody cares anymore, even ourselves. But we can use that technology to express ourselves in another ways, okay? And when we are doing this kind of silly projects, we are doing this kind of already mastered technologies to do small projects and express ourselves. So remember, as a maker, first rule, follow the rules, and once you know how to follow the rules and why the rules are there, break them, okay? It's really, really important. Okay, some crazy projects just to end. Clocks. People is obsessed with clocks. I don't know why. For 6 tenths, nowadays you have a microchip that it's the best clock that you can find, 6 tenths of euro, okay? But we love to create new clocks all the time. More original, more exact, you don't know, we have some LIDs clocks here from Back to the Future. I love that example there. It's a little robot that just changes an analog clock all the time. It's a really stupid idea, but just imagine to have it at your home. You know, every time you see it and you see that it's changing the hour, you smile a little bit. So that is really powerful, you know. You have someone that is smiling because this little body is changing the hour, you know, manually, and that person is a little bit happier. And that is really, really, really cool, you know, in one of the silly projects. There are, of course, traffic lights. This is an international joke that I'm not going to mention, but traffic lights are the bricks of the Arduino examples, okay? And people continue to do them because they are useful. But at the end of the day, just to resume this, a silly project has basics of mechatronics, study a creation of animated character, oh, it's there, okay, sorry. You know this project is a silly box, okay? And this silly guy, every time you click one of the switches, he just open and try to close it again, okay? With that face line there, okay? It's a really silly thing, but it involves basics of mechatronics, study and creation of an animated character and its personality, multiple servo control and the logic, basic knowledge of electronics, digital input, CAD design, 3D printing, basic and advanced programming, and so on. And what is the point here? The point here is that at the end of the day, when you are creating a silly project like this one, in reality, you are practicing to create a project that is going to be useful in the future, okay? The technology that I'm using here can be used for assistential, you know, management of people. So instead of this button that just yells, okay, we can have a smart button that a person, yeah, I love to push it, sorry. We can have a smart button, okay, that an old person has all the time with them, and this is working in so many countries, and it's synchronized with another system that will tell, you know, whoever this person is having a problem or is requesting help, okay? It's exactly the same technology. I'm just putting a goat and some nice things there, okay? So it's so important to start to play with things, to understand that you can do these things, first of all, and after that, that you can reply those things into serious stuff. Every time I will find a project related to this kind of technologies, I will remember this little project here, okay, and I will say, oh, this is really similar to this thing that I created. I just need to change these lines of codes and add this, and that's all. And this is one of the reasons I really push you guys to create silly projects without guilty, okay? This is the Open Left Race. I think it's another good example about a really silly game, but it's, you know, doing in the schools a lot of good job about educational things. Of course, just to finish, you guys have superpowers. And this is important. As makers, as developers, you guys have superpower. Yeah, this is the famous photo of a stock photo about how to solder, okay? If you know how to solder, this is terrible. Okay, please don't do that. You are going to get banned. Okay, don't do that. But that was so fun. But the point is that makers sometimes feel like MacGyver, right? Like we have these amazing tools and we can create whatever. Okay, but some things happen. And 2020 was a really difficult time for the makers movement, the world in general, right? We experienced the COVID pandemic, and it was terrible in so many ways, in so many countries. No personal protections, nothing, people were dying, was terrible. And all the society tried to help. In this case, the maker movement tried to, try to create some protections with 3D printing and trying to create some artificial breathing systems, respiratory system. And this is the case of Spain, for example, that the movement was huge. And we, in all the universities, in all the homes, we tried to, 3D print personal protections. Of course, they were not good enough, but it was good enough while the good things were coming. And it was an amazing movement, but at the same time was a pivotal point in the maker movement, because a lot of people got tired from that moment about the maker movement, because it was a terrible time. People were so stressed. A lot of people lost a lot of people. For the maker movement was like, okay, we realize we have superpowers. We are so proud that we can help, but at the same time we discover our limitations. So we have these superpowers, but those superpowers are not good enough. Okay, that was a terrible thing to discover that we still are discussing today. So the status of the open source community, and this is a question for you guys during these days, is here in Kosovo, what is the status of the open source community? I can tell you in Spain what is the actual status, but I would like to know yours, and I would like you have to have these conversations with your colleagues. What we should do to improve this status? Are the younger generations creating events like this amazing event, or not? Are they going to create these events? They know us? They know that they can do these things to put together, to be in person together, and to share silly projects together? That is the question, okay? So, you must share silly projects, always. Please do it. Open source projects are so important, and wherever you create something that you think is stupid and already person did it, please share it anyway. It's going to be useful for anyone, okay? Please share it. And, of course, please be careful about the loss of motivation, okay? This is the history of my life, so this is me. These are all my 1,000 unfinished projects, and this is a new project, like, oh yes, a new project, let's go to it, that at the end will be another unfinished project, and so on, and so on. Guys, please, finish the projects, don't be a perfectionist, and say, hey, enough is enough, I'm going to document, I'm going to publish it, and I'm going to share it with others. And no one will tell you, it's not perfect, just share it, okay? Just share it, and it will be okay. So, some examples of crazy people. Simon Geer is a really good example about the kind of silly projects that we are creating all the time. Just check the YouTube videos, they are amazing. She's a really good one, and at the same time, the most important thing, you do not have to prove anything to anyone, okay? Simone, at some point, had some healthy problems, some serious healthy problems, and she stopped these videos, these silly videos about silly products. And when she came back, she started to do other things, and that was okay, okay? So you don't need to justify the things that you are doing. You don't need to procrastinate. Okay, I connected the goat simulator to this goat, okay? Because the HAI, so it acts as a keyboard, so you can yell also on the goat simulator, okay? I spent like a whole night doing this because why not, okay? And yeah, be careful about procrastination, and just surround yourself, and this event is one of the best examples for it, surround yourself with people like you, okay? This is OSDE in Coruña, there in Spain, some amazing people here, and some amazing people dressed at T-Res, including, I think David Cuartillo is there, also there, okay? Surround you about people as crazy as you, please do it. You don't understand how important it is. And well, some silly projects for the community, please share it always with me, okay, on social network, your silly projects. And the conclusion is, this society is telling you all the time that your time is money. Your time is money. Do not waste your time. Do not waste your time because your time is money. You should be creating like true companies and doing all of these things and useful things and blah, blah, blah. This is not true, okay? When I was presenting myself, I was telling you that I was a maker. Some years ago, I started to define also myself through the people that I love, okay? So family, girlfriend, my friends, all of these people, some amazing makers there, okay? If you want to define yourself, most of the time you need to define yourself because we are social animals at the end of the day, through the person that loves you and you love, okay? And this is the best definition that I have of myself at this moment, okay? Yeah, your time is not money. Your time is life, okay? And this is some amazing photos from some different maker fairs and some different open source events, okay? You can see the smiles, you can see the interactions, you can see humans being humans, okay? So please, create silly projects as a technological rebellion, okay? Creating a silly project like the GOAT is to send a message to the society like, I don't care, I am the owner of my free time, and I can do whatever I want to with my free time, you know, and create new, silly, and amazing things. Thank you so much. Yeah. If not, I will be taking a coffee, okay, here, so we can talk, okay?
So there's going to be free lunch and the coffee and drinks and whatever served over there on the right side. Remember, at